the expected value. Now, going back to that Gregor Mendel screen where I found the mean number of green peas, where was it? Right here. When I found the mean number of green peas to be 6, what did I say about that 6? What does that actually mean? And that's a different mean than this mean. I said that's how many he would expect. If he went out and grabbed 8 peas every morning for 10 years, this is what he would be expecting. So it's not surprising then that the formula for expected value, if you look back to the picture of the scared llama or the confused llama, that's the same formula for the mean of a probability distribution, because those two things mean the same thing. The expected value is the mean. So sometimes I may say, find the mean of this probability distribution. Sometimes I may say, find the expected value of this probability distribution. You just have to understand those are two different ways of saying the same thing. So you could put right here that, if you thought it would help. The mean is the same thing as the expected value. Miss Tiffany, smile. Life is pretty good. This is the problem about life insurance. When you buy life insurance, you buy it thinking that it's possible you won't live through the year. And if you don't, you want to leave something for your family and your beneficiaries to meet their needs. And so really, life insurance is a gamble. If you live throughout the year that you pay your premium, then you lose your premium. But that's okay, you're happy to be alive. If you die during the year that you paid a premium, then the insurance company will pay your beneficiaries a claim. We want to know what the expected value is for a woman who buys an insurance policy through this Fidelity Life Insurance Company. There's a 0.9968 probability that a randomly selected 50-year-old woman lives through the year. When you turn 50 years old, there's a darn good chance you're going to make it to 51. But because there's a chance that you may not, you may want to buy some life insurance. Fidelity Life Insurance Company has a policy that charges $226 for ensuring that the female will live through the year. Now notice that's insuring with an I, not insuring with an E. They can't promise you that you'll live throughout the year, but they can sell you a policy to pay your beneficiaries if you don't survive the year. If she doesn't survive the year, the policy is going to pay out $50,000 to her estate as a death benefit. If the woman survives the year, what is the net change in her estate's value? Well, if she survives, she's not going to get any money from the policy. So really, she's just out the amount of premium that she paid. And since she has lost that money, the net change in her estate is negative. Her net change would be negative $226. Again, she's lost money, but she's happy to still be alive. If the woman dies during the year, what's the net change in her estate value? Well, the most common mistake would be to say if she dies, the net change in her estate's value is $50,000. But really, she hasn't cleared, or her estate hasn't cleared that $50,000 because at the beginning of the year, she paid for the premium of $226. So what she actually clears is $50,000 minus the price of the premium, and $50,000 minus 226 is $49,774. So this is the change in her estate if she survives. This is the change in her estate if she dies during the year. Now we can use those two numbers to come up with a probability distribution. Let C, C part, let the random variable X be the net change in the value of the woman's estate. Construct a probability distribution for the two possible outcomes: the woman survives the year or she doesn't. That's the only two possibilities. That's why we can make this into a binomial distribution. If she survives, we said she was going to lose the $226. So make sure you put that in as a negative. And what's the probability that she's going to lose that $226? Well, she loses it if she survives. And on the previous slide, we had a probability of 0.9968 that she will survive through the year. So there's a probability of 0.9968 that she's going to lose that $226. If she dies, the change in the estate is $49,774. What's the probability of that? Well, surviving and dying are complementary events. You can do one or the other, but not both. So if there's a 99% chance that she survives, there's about a 1% chance that she dies. We would just subtract that probability from 1, and we would get the probability that she dies is 0.0032. So this is a probability distribution, a binomial probability distribution, because there are only two possible outcomes. These two probabilities add up to 1. The D part says if if the female purchases the policy, what is her expected value? Well, remember, expected value is the same thing as the mean of the probability distribution. And the way that we find the mean of a probability distribution is by putting these possible outcomes in list 1 on the calculator, their associated probabilities in list 2, and then use 1BEAR-STATS to find the mean. Now, I've already entered those on my calculator. Here are the possible outcomes. Either she loses $226 or she gains $49,774. There's a 0.9968 probability that she lives, a 0.0032 probability that she dies. So if I exit the stat editor and go to 1BEAR-STATS, remember, your calculator may look a little bit different than mine. I enter list 1, comma, list 2. You may enter list 1 and then put list 2 as the frequency. Either way, the calculator finds that mean to be negative $66. Now remember, the calculator is treating this as a sample mean, but the mean of a probability distribution is actually mu instead of x bar. So we would say mu is negative 66. And I'm going to put dollars on there because that's what we're talking about. Now, what does it mean that mu is negative 66? That's not even one of the possibilities. We said either she's going to lose 226 or she's going to gain, the estate's going to gain 49,774. So losing 66 can't be actually what she expects. It can be the expected value for many such policies purchased, though. If 10,000 of these policies were sold, 9,968 of them would lose $226. 32 out of 10,000 would gain $49,774. So this negative 66 is not any particular woman's expectation, but the average of many such policies sold. So we could say average loss to the estate per policy is $66. Now, a loss to an individual's estate is a gain to the insurance company. The insured person, on average, loses $66. That means for each policy sold, the insurance company gains that $66. So if they sold 10,000 policies and made 66,000 on each one, then the company would profit $660,000. On average, they're just making $66 per policy, but if they sell 10,000 policies, then that's $660,000, and that's how insurance companies stay in business. They have to make a profit. Let's say, though, there was some freelance insurance company that didn't wish to make a profit, they just wanted to break even. What should they charge for the policy if they simply wanted to break even? Well, what's the current price of this policy? It's $226 per year. And of that 226, their average profit is $66. So if they didn't want to make a profit, they could just charge $66 less for each policy. They could sell each policy for $160 if they didn't care about making a profit. So again, expected value is the same thing as the mean of a probability distribution. Because this was a binomial probability distribution, only two possible outcomes, we could set up this table and find the expected value or the mean in one var stats.